Hey, pre-calc kids, and welcome to day 7 of the notes. You should be starting a new packet today. This is where we're going to be starting to get into some new stuff. So far, everything you did last couple of weeks should have been more or less review of some geometry things. And today, and along in the next few days, we're going to start getting into some stuff that you probably haven't seen before. Okay, so first thing that we're going to need to know is what is a radian. So I mentioned on our calculator last week that we want it to be in the mode degrees as opposed to radians. There is a use for having it in the radians when we get into more uses of trigonometric functions, so more uses of sine, cosine, tangent. And we're going to want to know what a radian is versus degree, and they are related. So a radian is another way of measuring an angle. Okay. The way that we're going to find radian is using this formula. So our radian angle theta is equal to S over R, where S is the arc length. Okay, so then on question 1, it says, let's simplify that formula a little bit using what we know about arc length. So last week, or on Friday, we talked about the formula for arc length was S equals n degrees over 360 degrees times 2 pi r. So it was a fraction based on the central angle times the circumference, or 2 pi r. Okay, so if we want to rewrite this equation, we have theta equals n degrees over 360 degrees times 2 pi r over r. And so what happens here is we can cross out a couple things. We can cross out the r's, and we can simplify 2 pi over 360 to 1 over 180. So we get n degrees times pi over 180 degrees. Okay, so if I know my angle in degrees, all I have to do is multiply by pi over 180 to get it into radians. And we'll do a couple examples here in a minute about those. Okay, we might want to go the other way as well. So if I have theta in radians is n times pi over 180, well, let's say I wanted it to be in degrees, but I have it in radians. I want to get this part by itself. So I'm going to, instead of multiplying by pi over 180, I'm going to multiply by 180 over pi. Okay? So to get rid of this pi over 180 here, I need to multiply both sides by, let me erase that, 180 over pi. Multiply both of the sides. So 180 over pi. Because those 180s then cancel and the pi's cancel on this side. So if let's say I had my angle in radians, but I want it in degrees, I'm going to do my angle in radians times 180 degrees over pi. Okay, so on question 3, we're going to go from degrees to radians. On question 4, we're going to go from radians to degrees. Okay, so on 3a, we have 60 degrees. So if I want to go from degrees to radians, I do times pi over 180. So I'm going to do 60 times pi over 180. And for most of these, we're going to want to leave them in terms of pi. We talked about that last week. We just don't multiply by the pi button on the calculator. So all we're really doing here is simplifying this fraction. So we have 60 degrees over 180 degrees times pi, and 60 over 180 is going to simplify to 1 over 3. So we're going to get pi over 3. Okay. Same thing for the 30 degrees. We're going to multiply by pi over 180. So we're going to get 30 degrees over 180 degrees times pi. And 30 over 180 simplifies to 1 over 6. So we get pi over 6. Same thing for 45 degrees. Multiply by pi over 180. That one's going to be 1 over 4. So we get pi over 4. Okay? Now, if we want to go the other direction, like on number 4, we're given an angle in radians and we want to go to degrees, we're going to multiply by 180 over pi. Okay? So, on 4a, we have 5 pi over 2. We're going to multiply this by 180 over pi. And what's going to happen here is the pi's are going to cancel. I'm going to do 5 times 180, which is 900 degrees. And I still have this 2 here, so divided by 2. And I'm going to be left with 450 degrees. Okay, on to 4b. We've got 5 pi over 3. And I'm going to degrees, so we're going to have times 180 over pi. Those pi's cancel again. We're going to get 900 over 3, which is 300 degrees. And for that last one, for C, we're going to multiply by 180 over pi. Pi's cancel. We get 540 over 4. And if I can do that real quick in my head, that's 125 plus 8, 135 degrees. Well, maybe I can't do that in my head. Maybe we use the calculator just to be sure. 540 divided by 4, 135. Okay, good. Didn't trust myself, but I was right. Okay, I'm going to pause there for a few seconds, and then we're going to go to part 2. Okay, we're on to question 5 here. Okay, and it's saying if we start our angle at 0 radians at the positive x-axis, how many radians and degrees would each angle be? Okay, so we're saying 0 radians is right here at the positive x-axis. Okay, if it's in 0 radians, it's also 0 degrees, because if I multiply 0 by pi over 180, or 180 over pi, I would get 0 again. So 0 radians or 0 degrees. Okay, then it's asking, what about the other axes? So this is the positive x-axis. What about positive y, negative x, negative y axes? Okay, so if I go and turn right here, that makes a right angle. Okay, and we know that a right angle is 90 degrees. If I do another right angle to get down here, I'm at 180 degrees. If I do another right angle, I'd be down to 270 degrees. And if I did another right angle, I'd get back to the starting place, which was 0 degrees. We might also put 360 degrees here. Okay, so those are the degree measures for each of the axes. What about the radians measures? Well, for the radians measures, I'm multiplying by pi over 180. So 90 over 180 simplifies to 1 over 2. So this would also be pi over 2. For the next one, 180 over 180 is 1 times pi is just pi. For this bottom one, 270 over 180 is the same as 3 over 2. So this is 3 pi over 2 at that angle. And if we came the full circle, it was 0, it would also be 2 pi. Okay, I'm going to go through the next part B, pretty quick. We have these different angles marked in radians. It wants us to mark them in degrees. So this is just like question 4. So we're multiplying by 180 over pi. So if I multiply pi over 6 by 180 over pi, I get 180 over 6, which is 30 degrees. And maybe I should write that in red so it matches with the rest of my drawing here. So 30 degrees. If I multiply 5 pi over 6, I'm going to get 150 degrees. Again, I'm multiplying it by 180 over pi. 7 pi over 6, I'm going to get 210 degrees. And 11 pi over 6, I'm going to get 330 degrees. Okay. So part C says, what do you notice about the 4 angles as they relate to the x-axis? Okay, so let's start over here. What do we notice about 30 versus 0 and 330 versus 0, or 330 versus 360? Well, 0 and 360 being the same. This angle and this angle are only 30 degrees away from the positive x-axis. Over here, on the negative x-axis, 150 or 210, those are each only 30 away. So each angle, for question C, each angle is only 30 degrees, or 30 degrees was just pi over 6 radians away from the x-axis. Okay, and this is what is going to be known as a reference angle. So a reference angle are all angles that share the same distance from the x-axis. Okay, and specifically for that reference angle, we're looking at the smallest possible angle. So 30, 150, 210, and 330, those are all the same distance from the x-axis. They're all 30 degrees away from the x-axis. So our reference angle is the 30 degrees. It is the pi over 6 using radians. Okay, so if I were to have 4 pi over 3, and I want the reference angle for that one, well, so let's figure out what 4 pi over 3 is in degrees to help us think about this in terms we've used before. So I'm multiplying by 180 over pi. I'm going to get 720 degrees over 3, or 240 degrees. So 240 degrees, if I maybe went back to the circle over here, that's going to be something down here. That's going to be a 240 degrees down over there. Okay? 240 degrees from the x-axis is 60 degrees off of it, because I'm 60 up from 180. Okay? I'm closest to this x-axis right here. I'm not close to this one over here. So I'm going just 60, the closest one up. So my reference angle there is 60 degrees, or pi over 3 radians. Okay, and it's saying what other ones have that same reference angle. So we know 4 pi over 3 shares the reference angle pi over 3. Which other ones have that? Which other ones are 60 degrees up? Well, I could have 60 degrees this way, which is back to 120 degrees. We already have this 60 degrees. There's also a 60 degrees over here. at 300. Okay. Then we just need those in radians again. Okay, so we have pi over 3. This one ends up being 2 pi over 3. And the one down here at 300 is going to end up being 5 pi over 3. All right, question 7. In general, how many angles that are 2 pi or below share the same reference angle? Well, when I'm saying 2 pi or below, I'm saying before we complete that first circle, how many of those angles are going to share the same reference angle? It's going to be the same for all of these. It's going to be 4. Okay. We had 4 that were 60 degrees off of the x-axis. We had 4 that were 30 degrees. If I chose 72 degrees, I'm going to have 4 again. Okay. 4 share a reference angle. All right, and we have one more part to do here.